So far, we've been talking about displaying graphs for the distributions that had only one variable. So we were talking about, scores on the exam or heights. All of these were just one variable stats. But this now we're gonna look into two categorical variables, and we are on page 26 on our notes. And when we're dealing with two categories, then we're gonna display it or record this information into what is called a contingency table. A contingency table is a display of two categorical variables. The rows contain the categories for one variable, and the columns contain the categories for the other variable. So, for example, I have a table here, and we have two variables. We have the cars driven by either Mesa College staff or student. So student or staff is one of the variables that we're observing. Another variable that we're displaying here is the origin of the car, whether the car is American, European, or Asian. The cells contain the frequency of cases in the sample with overlapping outcomes for the two variables. So, for example, this value of 108 here, it represents the cars that are both driven by students and American at the same time. For example, if we look at this cell, 15, that represents the frequency of the cars that are both European and driven by a staff member. So that's what this means, that it's overlapping outcomes for both variables. It's both driven by staff member and a European. So if it's driven by a student and a European, then we're looking at the frequency of 33. If we're just looking at all European cars and we don't care if it's a student or staff, then the total of those cars would be 48. There is, let's now talk about another feature of this table. Is that we have margins here. So we have totals for all the rows, okay? And we have totals for all the columns, column categories. And those are called marginal distributions, okay? So this is the distribution for the origin of a car driven. And this is the distribution for student versus staff drivers. Okay, so these are marginal totals. These distributions are called marginal distributions. And then we also have a grand total. So this is the grand total. So this is the total for all of the drivers included in this survey. And the inner cell frequencies right here, these guys right here, they're called joint frequencies because they represent the two variables together. So for example, 33 represents the number of students that drive European car, and 104 represents how many staff members drive American cars. So this is the joint frequencies. This is staff and person who drives American car. This is 15, for example, represents both the staff member and the person drives European car. So forth. So I hope you understand that. Let me know if you have any questions in the comments or during the class. Now let's use this table to answer some of the questions. So here's our first question. What % of all the cars surveyed were European? The things to note here is that they're talking about all the cars, and they want to find out how many of all the cars are European. So we're going to go to our original table and see the total for European cars is 48. Okay, and then because they're talking about out of all the cars, then they're looking at all the cars, then our total is going to be 362. So again, the formula for figuring out the percentages is basically, this is our focus group divided by the total multiplied by 100%. So that's the formula that you're going to have for figuring out the percentage. So our focus group here is European cars. Okay, so we have 48 of them. So 48 divided by the total. Well, the total will differ in depending on the question. Okay, so for this question, they're talking about all the cars. So we're going to use our grand total, 362. 362 multiplied by 100%. So let me put it in the calculator. You may pause the video here and do the calculations yourself. In fact, I encourage you to do so you get familiar with your calculator and you don't struggle during the test. So here you go. I got 13.26%. My decimal here was 5, but right after the 5, there was a 9. So I rounded up. Again, 4 decimals. And there you go. That's the percentage that I got. The next question is, what % of the American cars were owned by students? Okay, so again, let's dissect this sentence. So just heads up, in mathematics, there is no fast reading, okay? You have to actually read your problems, your assignments carefully, make sure that you understand what they're asking. So first of all, what's the total group that they're looking at? Well, they're looking at the American cars. And the question is, out of those, how many were owned by students? Okay, so for the total here, I'm gonna write all the American cars. That's my total because this is the group that they're taking out the students, right? The cars that are driven by students. So this is my total group that we are looking at. So for the American, we have 212. And how many out of those, just that group, how many is driven by students? Well, it's just 108. So do you see the difference? Here, they were looking at all the cars in question 1. In question 2, they're looking only at the American cars. That's why our total changes. It's not 212. It's not 362 anymore. It's 212 because we're looking at American cars only. Okay, and multiply by 100%. we get 50.94%. Alrighty, let's move on. So question number 3, what percent of cars were Asian and owned by a staff driver? Okay, so here, see, we have Asian. Let's talk about the wording again. Asian and owned by staff. So that's your joint variable. We are applying both values. It's Asian and owned by staff. So that's the value that we find in the staff column and the Asian row. So 46. 46 cars were both driven Asian and driven by staff. So 46 is our focus group. 46. What percent of cars? Again, here they're implying all of the cars. So for the total, we're gonna put our grand total 362 because they're implying that we're looking at all of the cars. What percent of, we could rewrite this question saying what percent of all cars were Asian and owned by staff? Okay, so times 100% equals 12.71%. Don't forget the percent symbol because without it, it means something totally different. Okay. Create a conditional contingency table conditioning on the type of a driver. Okay, so conditioning on the type of the driver. So what that means is that we're gonna look at these two groups, the type of driver as separate groups. Each of one is 100%. So 197 student drivers would be 100% of student drivers, and 165 is 100% of staff drivers, okay? And then we're gonna figure out percentage of each. All right, so let's do this. Let's create this table. We have, okay, so we have student and we have staff. And then we have total. All right. And then we have our different types of cars: American, European, and Asian. All right. So for students, so we're talking about percentages now. 108 out of the total of 197 is going to be 108 over 197. And then we're going to have, for the next one, for the European cars, it's 33 out of all student drivers, and then 56 out of all student drivers. And that's hopefully going to be 100% of all of the student drivers. Now we're going to look at all of the staff drivers, 100% of them. So 104 that drive American, that's 104 out of 165. And then the next one for Europeans, European cars for staff drivers is going to be 15 out of 165. And for those who drive, staff members who drive Asian cars, there's 46 out of 165 staff members. So for creating this column, we are only looking at staff members as 100%. And for this column, we're looking at all students as 100%. Okay, and we could also do totals. So for the totals, we have 212 who drive American, but in this case, we're going to divide by the grand total, 362, and then 48. We don't need to do that here. That's not what they asked us to do in this question. They only asked us to condition on the type of driver. So basically just do these two columns, but there is nothing wrong with doing the totals. Okay. And I'm gonna pause here and I'm gonna come back with the actual percentages calculated here. And like one of my coworkers says, through the magic of technology, we have our table already completed. And we have percentages. We converted our fractions into percentages. That's what we did with the calculator. And so hopefully all of your percentages should add up to 100% in percentages in one column. So for students, you have 54%, 54.8 that drive American cars, and then 16.75% who drive European cars, and 28.43 who drive Asian. So the total should be 100% for students. And then we have 100% of staff and how they're divided. And also we have 100% for total and how they're divided, the totals. All right. So there we go. Okay, so one of the questions that I may ask you when looking at this table, is there is there a correlation between what kind of car a person drives and whether it's a student or staff? Actually, it's the other way around. If student staff, does it depend on what kind of car they're going to drive? So if you compare these percentages, you can what you can get from this picture is that for the Asian cars, the percentages are similar, right? We have 28 versus 27%. But now for European and Americans, the percentages are different. So this between American and European, there are more student than staff drive European, and for Americans, American cars staff, a greater percentage of staff drive American compared to the percentage of students. Okay, still majority drive American cars. Now, at this point, I realize it's a little bit subjective looking at these percentages and say, with this one is significantly bigger, because for Asian cars, there's still a difference, but we just ignore that difference because it's insignificant. So right now, it's subjective. In later chapters of this course, we're gonna look how to figure out if there is a significant difference or not. But for now, we'll just follow this rule. If the difference is bigger than 5%, then it is significant. Let me write it down. If the difference is bigger than 5%, we will consider it a significant difference. Okay, so here we have a difference of 0.8, 0.9, between 0.8 and 0.9%. I mean, 9 and 8%. And here the difference is about, so 16 minus 9 is about 7, 8% difference. So it's greater than 5, so it is a significant difference. There is one more thing that I want to mention right here is how to display two categorical variables. And we're going to talk about split bar chart and also stack bar chart and mosaic plot. So here for this data set, a split bar chart would be like we will have our chart for students and for staff. And we would have a bar for the American cars for students, which is 54%, and then for staff, which is 63%, so a little higher than the 54. And then for European cars, we would have 16.7, so it's significantly less. And here it's 9%, and then another one for Asian cars. So about like it's not really good drawing, but you understand what I'm saying, right? So this would be a split bar chart, and there is also a stacked bar chart. So for the stacked bar, we would have two identical bars. Okay. Identical. They're not. Okay, but pretend they are. Okay, so this would be staff, and this would be students. And then we would divide each bar according to the percentages. So for student one, we have 54.2 right here. So this would be for American cars, and then 16, almost 17% here and 28% here. So this would be European, and this would be Asian. Okay, now for staff, we have 63.3, so a little bit more than. So 60, this is American cars, 63.3%. And then for European cars, that would be like a smaller section. I don't know if you can see that it's smaller, but that would be smaller. And then Asian. So this would be an example of a stacked bar. So let's write percentages. So we have, this is for students. So this is 54.82%, and European, no room, but okay, I'll try 16.75%, and this is 28.43%. And then for staff, this is 63.03, 09.09, and 27.28. Okay, so and then you would color it nicely as well, just different colors, just to create a nice visual. Well, this is it for this video. I'll see you in the next one.